Dear participants, welcome to this session of 5th International Symposium on Multidisciplinary Studies and Innovative Technologies. My name is Emir Köksal. I'm a professor doctor in the Department of Mathematics of 19 Mayıs University. There are 8 presentations in this session. The duration of each presentation is 10 minutes. The first speaker is Ali Hamid Farei, and the title of his talk is Enhancement Trust Management in IoT to Detect On-Off Attacks with Koja.
Yes. Can I start?
We'd better wait 1 minute, okay?
Okay.
You can start.
Okay, thank you. My name is Ali Hamid Farei, Department of Computer Engineering at Kocaeli University. Today, I'm going to talk about enhancement trust management in IoT to detect on-off attacks with Koja framework, running title OOAS. This work prepared by Ali Hamid and Karim Küçük. So this is the outline of our work. I will introduce the types of attacks in the IoT. Then I will explain the on-off attacks problem. Also, I will present our proposed solution to detect on-off attacks. In fact, it depends on the artificial neural network multi-layer perceptron because it is able to detect on-off attacks and classify this type of attacks. Actually, we used the Kentucky operating system to apply and implement the scenario of on-off attacks. Kentucky operating system is a powerful simulator. Also, Kentucky operating system is an open source used for simulate the IoT environment and wireless network. It also has a 6LoWPAN protocol to capture the node data. Also, we utilized the Microsoft Machine Learning Studio to analyze the data and display the results. It is an online service provided by Microsoft company. Through this service, we can choose the best algorithm in machine learning and neural network as we want. We can add it or delete the models without breaking our experiment. Then I will talk about our full implementation models and results. We know that Internet of Things is developing day by day. Completely, we depend on it in our life. Therefore, currently and in the future will increases the concern of security threats and trust management, especially the systems which work perfectly without human intervention. Also, we know the security threats are open issues for the researchers, so that there are many types of attacks in IoT, like self-permissions attacks. The others are used direct service quality trust assessment and feedback propagation to detect self-permission attacks, and also bad-mouthing attacks. The others are used credibility to rate a recommender, and so on. Let us to focus on on-off attacks problem. Our method to detect on-off attacks depends on the artificial neural network multi-layer perceptron. So in this slide, I will explain the scenario of on-off attacks. So on-off attacks are considered a type of selective attacks. means that inconsistent behavior, like a multi-person, one important characteristics of IoT is support multi-service approach, means that traditional methods are not convenient to detect on-off attacks. Why? Because on-off attacks are exploited the network through two problems, through time and inconsistent behavior. Through time, the nodes are still on status all the time. Through this time, maybe bring any malicious node. So we know each device has two status. The on status is considered the attack status because the nodes is active mode. The off status is a normal status because the node in idle mode. So if node 2 is still on status all the time, maybe bring any malicious node like node 4. So this is the problem of time. Now, inconsistent behavior. The malicious nodes are sending data trusted and untrusted alternately. For example, if node 4 at a time send data to node 2 as a trusted, other time as an untrusted data. So node 2 is confusing between incoming data. This data is coming from trusted node or from untrusted node. So if the network, if this condition are achieved in the network, means that the network is injected with by on-off attacks problem. So to solve, we solve this problem. We solve time problem by monitoring all the time of on status. We discarded off status because the node in idle mode doesn't bring any node maliciously. As we say in this equation, T represents the time of on status and W represents the adjust factor between status. Also, we solve the inconsistent behavior by monitoring all the futures of nodes. As we say in this equation, T represents the futures of nodes, and W represents the adjust factor between nodes. If we are observed from the first equation and the second equation, actually the neural network work like this. So we use the artificial neural network multi-layer perceptron to help us to detect on-off attacks. Our model is divided into 3 phases, starting with simulation phase, ending with artificial neural network multi-layer perceptron. So that artificial neural network perceptron is able to classify node data, this data with on-off attacks or without on-off attacks. In simulation phase, we used Kentucky operating system to create real data set, and we applied and implemented the on-off attacks scenario. So we initialized 3 nodes are active all the times, as we see here, node 4, 8, and 12. These nodes are vulnerable to any risk. Also, we initialized inconsistent malicious nodes, node 9 and 10. As we say in this figure, node 8 for 12 are take a long time in on status over time compared to other nodes. So these nodes are vulnerable to any malicious nodes like node 9 and 10. How did we implement the inconsistent behavior? To apply the inconsistent behavior, we consider the mail form packets as a malicious node that behaves as a trusted and untrusted node, so that the mail form packet is longer than a single frame and it is not resampled. One of time node G resampled the packet, another time not resampled it. For example, if node I sends the packet to node G and node E cannot resample the packet, so that node E is considered incoming packet from untrusted node, and vice versa. So here, our proposed model flowchart and real implementation of our model. We initialized the real network, as we say in the first, and we implemented and applied the scenario of on-off attacks. We used 6LoWPAN protocol to capture all the data. Then by using Wireshark, we opened the backup file. Then we converted the backup file into CS file. Then the data set is ready. All these steps are implemented in Kentucky operating system. Then we selected column in data set that appears in application programmer interface as input. Also, we normalized our data. Then we split the data into training data and testing data. Training data represents 70% and testing data represent 30%. Then the data is entering into artificial neural network multi-layer perceptron. Scored model shows the result. Also, the evaluate model shows the performance of our model. All these steps are implemented in Microsoft Machine Learning Studio. As we see here, this is the real implementation. Yes, here the result and data set. As we see in this data set, we can see the network are injected with on-off attacks, because node 9 is inconsistent malicious nodes connected to nodes 4, 8, 12. These nodes are vulnerable or all the time still on status, so that the result is 1. If the scored label equals 0, means that the network isn't injected with on-off attacks. In this slide, the performance for our models. If this line moves to 1, means that the accuracy increase, so that the accuracy in our model approximately equal 99, and the precision equal approximately equal 98%. Also, we created application programmer interface to detect new devices with on-off attacks or without on-off attacks. All you can, if you want to check your devices injected by on-off attacks or not, you can just put the features or parameter here and click on the test. If the scored label 1 means that your devices is injected by on-off attacks. Conclusion, we proposed a model to enhance trust management in IoT to detect on-off attacks behavior by creating a real data set using the Kentucky operating system based on the behavior of on-off attacks that exploit the network through them. And we applied the scenario. We analyzed and we monitored the data by using an artificial neural network multi-layer perceptron to classify the nodes as a malicious or normal. These nodes will, with on-off attacks or without on-off attacks. Finally, we implemented our method by using Microsoft Machine Learning Studio. Additionally, we create a web service to verify from new nodes behaviors and classify quickly to a normal or malicious nodes. Future work, we will apply other attack scenarios in the IoT environment to detect them by using our model. This end of my presentation. Thank you for listening. If anyone have any question, we are ready to answer this question or any note.
Is there any question, comments, or remark? No question. Thank you very much for your presentation.
Thank you.
The second speaker is Ivan Ralev. The title of his talk is Gesture-Based System for User Interface Control.
Dear professors, colleagues, and guests, my name is Ivan Ralev, and I am a PhD student at the University of Ruse. Today I am going to present our paper co-authoring with Professor Georgi Krastev. The following topic is gesture-based system for user interface control. At the beginning, I have to explain what is human-computer interaction. It describes the way of communication between a person and a computer. And the intelligent human-computer interaction describes the way in which this communication takes place in a way similar to human-to-human communications. For example, hand gesture recognition, brain activity recognition, and so on. The paper presents a console application that allows the user to control his personal computer through a hand gesture recognition. The main research that is planned to be conducted with the proposed tools are the presence of variable factors leading to uncontrollable changes in the background of the film scene, assessment of the influence of the different distance from the camera, the position of the body, the clothing, the presence of attributes on the hands of the gesture, for example, gloves, watches, or jewelry. The development is based on the Creative Inter RealSense camera and RealSense SDK, which open up great opportunities for developing gesture recognition application. At the same time, the SDK also supports algorithms for gesture, speech, and face recognition. The interior sense can also perform skeleton-based tracking. The programming languages that are supported are Java, C, C++, and Python. From the use case diagram on this slide, we can see the main functions that the user can perform. Uh, Play and stop music or movie by hand gesture in VLC player, increase or decrease the volume, increase and decrease the scale of Google Maps in the web-based version, changes the mood of the maps, road map or satellite map, view photos of the computer in albums, control YouTube place or stop video, switch between full screen and default screen by hand gesture. Gesture recognition is based on tracking key points. Each gesture is combination of different segments, and each segment in itself represents a specific movement. And when all these segments are connected, the gesture itself is obtained. It can be seen from this slide that the execution of a certain gesture can pass into one of the following states. Loose, the gesture is cancelled. The user has moved his hand in a direction that contradicts the current gesture. After the gesture is stopped, the next one is immediately generated. Pause, the gesture is not interrupted, but the user does not perform the next part. The application will check the result of this part again as soon as possible before the gesture stops. A possible reason for the result pause is the slow execution of the gesture by the user. Success, the user has completed all parts of the gesture, and after a short period of time, the system starts monitoring the new gesture. After detect the and recognize a certain gesture from the creative camera and its SDKs, this can be linked to the performance of a specific action. This slide summarizes the gestures that are used. Fist is used for zoom out in Google Maps, spread fingers for zoom in Google Maps, swipe left for previous picture, swipe right for next picture, thumb up for pause music or video in VLC player, thumb down for stop music and video, V sign for change map type in Google Maps, swipe up for volume up, and swipe down for volume down. For example, after recognize the thumb up gesture using the capabilities of the Java programming language, an object of type robot is created, which in turn can simulate press a certain key on the keyboard, which in this case is space. In the VLC player, this button is used to play or pause audio and video content. On the left photo, you can see the execution of the gesture full pinch, which is recognized as a gesture fist. The SDK documentation tells you not to use this gesture together in one application. On the right photo, you can see the execution of the gesture spread finger. The camera is mounted on the upper right corner of the monitor. On the photo, it is surrounded in red color. The tests performed with the creative interior self camera are under different conditions. Temperature, the distance between camera and users is 1 meter or a half meter. He used his left or right hand, wear watch or no. During the test, it was found that the fist and spread fingers gestures were the easiest to detect, and swipe left, swipe right, swipe up, and swipe down were the most difficult. At a distance of 1 meter, it is difficult to detect a gesture. It is less difficult if the background is multicolored. Clothing, accessories, whiting, and hand, right or left, no significant difference. After test and analysis of the results, it is understood that the camera of the creative interior sense can be used as a human-computer interaction for gesture control of certain software. Gesture detection and their use to control a device or software is an important part of the study of intelligent human-computer interaction, and with the development of computer technologies, we find increasing use. Thank you for your attention.
Is there any question, comment, or remark? No question. Thank you very much for your presentation. Next speaker of this session is Sigit Widianto. The title of the talk is Image-based tomato maturity classification and detection using faster RCNN methods.
Okay, thank you. Good afternoon, everyone. My name is Sigit Widianto. I will present our results about image-based tomato maturity classification and detection using faster RCNN method. I and my research team from Department of Computer Science, Gunadharma University in Jakarta, Indonesia. In Indonesia, it's about 2 p.m. here. Okay. For the background of this research is tomato is flowering plant that called Solanum lycopersum. of the Nightshade family, Solanaceae, that is cultivated extensively for its edible fruits. Tomato also has high demands on the market as it's used for daily needs and occur for many cuisines. The fruits are commonly eaten raw in salads, served as a cooked vegetable, used as ingredient of various prepared dishes and pickled. Tomato come in several colors as red, orange, and green. This difference of color caused by their maturity level. By using greenhouse in tomato cultivation, all of which can be controlled, technology is also needed to monitor the maturity level of tomatoes. So an image-based and learning method that can classify and detect tomato maturity in real time is needed to support the monitoring system. So what is the research purpose? The first is to confirm how a deep learning method such as faster LCNN, faster region-based convolutional neural network model, could recognize tomatoes maturity by its color. The second one is to implement the method to classify and detect the tomatoes maturity in real-time processing by recognizing multiple objects in an image. So what the method? Our method is by the first one is collecting the data that obtained from greenhouse that contain 1,800 tomato dataset images that are separated into three classes: red, orange, and green. And the dataset was separated to be trained and validation set. And the next process in the trained dataset was learned by faster RCNN until we can got the model that contain knowledge of tomato maturity based on color image. And then the last is detecting the tomatoes that has maturity level by putting box to the object in one image. The data itself was collected from tomato that planted several periods from February 2020 until August 2021. The image just taken using a camera with resolution is about 5 megapixels. And the resolution of single tomato image that used in training phase is 150 by 150 with 3 layers RGB. So it's cropped by students that working in this research. So we have 1,100 data sets for the tomatoes classification. The color maturity level that used in image label, we can see the samples with red, orange, and the green. So the architecture of faster RCNN, faster RCNN is an extension of fast RCNN. It is the latest generation of object selection method, show impressive result on object detection. We have convolutional layers, feature maps, and then the core of this faster RCNN is region proposal network. We have after that we use proposal, and we have region of interest pooling and classifying. For region proposal network, or RPN, is a quick task that is usable for researching on the input image, the possible location of objects. The position of the object in the image has the possibility that the object is restricted from a region known as the region of interest, or ROI. RPN takes image of various size as input and output as set of rectangular object proposal, each with an objective score. And then in the region-based proposal networks, the image is initially entered into the convolutional network. The input image is forwarded to the last convolutional layer network that display the feature maps. So sliding windows are placed here, are placed on each part of the feature maps. Sliding window maps are usually taken from the size of n by n here, marks that according to each sliding window. It simultaneously predicts several proposal region. where the maximum possible number of proposal for each location is, we can denote it as K here. So we have the result for the modeling. The modeling is trained until 58 push and bed size is 13. The loss is calculated on training and validation, and its interpretation is based on how well the model is doing in these two sets. It is the sum of error made for each example in training for validation sets, and we can compare with the accuracy metric that is used to measure the algorithm performance in interpretable way. It is the measure of how accurate the model's prediction is compared to the true data. So from the chart, we can see the convergence of the validation loss and validation accuracy. Then the object detection result, we can see the object is classified and detected by putting bounding box with the confidentially information. Confidentially is actually is getting from F1 measurement here that calculate by precision and recall. For example, in the first image, the first red tomato is about 97%, and the second one is 6%, and the green one is 97%, and so on. This is only in the sample. Okay, we test in 25 images that we have the average for green color is about 96.90%, and the orange colors is 95.90%, and for the red colors is 96.10%. For the conclusion, based on the result, the tomato maturity level by its color have been correctly identified. So faster SCNN working very well for doing object classification and detection tasks. The accuracy for classification in validation stage about 80.70%. For the object detection, the model has confidentiality about 96.20% in average to detect the tomato maturity. For the future works, this result will be implemented in smart monitoring for hydroponic system that built with drip irrigation also. And we have some system there with the IoT. And then for make a better result in detection object, it needs to use small object as a sample, because when detecting the small tomato, there's problem in detecting this one. Okay, this is the reference, and thank you. Terima kasih.
Is there any question, comments, or remark? No question. Thank you very much for your nice presentation.
Thank you.
Next speaker is Matthias Baumgartz, but he is absent. Okay. The next two presentations will be given by Mine Tülin Zateroğlu. The title of her first talk is Evaluating the Sunshine Duration Characteristic in Association with Other Climate Variables. The title of her second talk is Statistical Models for Sunshine Duration Related to Precipitation and Relative Humidity.
Başlayabilir miyim?
Buyurun, başlayabilirsiniz.
Tamam, teşekkür ederim. Şimdi benim iki çalışmam var aslında. Birlikte ikisini bir sunum yapacağım ortak bir şekilde. Yani peş peşe olacak ama buradaki ifadeler aslında ilk baştaki ifadeler ikisi ortak. Tanımlarda bu ortaklık var aslında. İlkinden başlayayım. Güneşlenme müddeti ya da süresi olarak ifade edilen bu iklim elemanı yani niçin önemlidir? İlk başta ondan bahsedeceğim. Bu değer, bu güneşlenme müddeti, bu iklim elemanı, meteoroloji ya da iklim başta olmak üzere birçok alanda bu kullanılan temel bir veridir. Yani aslında meteorolojik ve tarımsal amaçlı uygulamalarda yaygın bir şekilde kullanılmaktadır. Özellikle bu tarımsal amaçlı uygulamalarda bir araziye ulaşan güneş enerjisi miktarı yerine enerjinin ne kadarlık bir süreyle bu geldiği çok daha önemli olduğundan özellikle bu zirai araştırmalarda bu değer çok yaygın bir şekilde kullanılmaktadır. Güneşlenme süresi yeryüzüne ulaşan güneş enerjisinin miktarının da hesaplanmasında yani tahmin edilmesinde aslında çok önemli bir etkendir. Bunun dışında enerji yatırımlarında da bu bilgiden çok yaygın bir şekilde bir sonraki bir tahminde ya da bu enerji yatırımlarının hesaplanmasına bu değerden yararlanılır. Bunun dışında otomobil rengi yani günlük yaşam üzerinde aslında birçok alanda etkisi var. Hatta insanların ruhsal sağlığı üzerinde bile etkisi olduğuyla ilgili bilimsel makaleler yapılmıştır. Çok sayıda çalışma göstermiştir ki yeryüzüne ulaşan güneş enerjisi miktarı diğer meteorolojik veriler yani iklim elemanlarından yararlanarak tahmin edilebilmektedir. Dolayısıyla güneşlenme süresi de güneş enerjisiyle ilişkili olduğundan bu değer de diğer iklim elemanlarıyla yani meteorolojik verilerle aslında bu ilişkilidir ve bu veriler yardımıyla da tahmin edilebilir. Güneşlenmenin ayrıca zamansal ve mekansal değişimi de çok önemlidir. Bunlarla ilgili de bazı bu çalışmalar mevcuttur. Birçok alanda aslında bu veri bir yaygın halde bu veriden yararlanılmasına rağmen bununla ilgili ülkemizde ve bu dünyada yapılan bu çalışmalar, bilimsel çalışmalar aslında yetersizdir. Güneş enerjisi üzerine yoğunlukla bir çalışma mevcuttur. Peki tanım olarak nedir? Aslında Dünya Meteoroloji Örgütü şöyle bir tanımlama yapmış. Güneş radyasyonu 120 watt bölü metrekareye ulaştığı ya da bu süreyi aştığı bir zamanların bir toplamı olarak ifade etmiş ve saat olarak da birimi kullanılmış. Peki nasıl ölçülür? Aslında yer gözlem istasyonlarında, meteorolojiye ait yer gözlem istasyonlarında heliograf adı verilen cihazlarla ölçülür. Bu cihazda bir cam küre, yan tarafında bir fotoğrafı var, bir cam küre. Bunun altına yerleştirilen bir diyagramdan oluşur. Güneş ışınları bu cam küreye geldiğinde odaklanarak bu diyagram üzerinde bir noktada yoğunlaşır ve bu noktayı yakar. Gün boyunca, tüm gün boyunca bu işlem devam eder. Yakılan noktalar düz bir çizgi oluşturur ve bu çizgide bir derecelendirmeyle o güne ait bu süreyi bir değer olarak verir. Şimdi burada aslında yapılan ölçümler noktasaldır. Bir bölge için yapılır. Bölgeler arasındaki noktalar için hangi değerde olduğu bilinmemektedir. Bu da bazı interpolasyon yöntemleriyle aslında bu bilinmeyen noktaların bir tahmini yapılır. Şimdi bunun haricinde de bu kısımda yani bu güneşlenme ile ilgili bu verileriyle ilgili bir sıkıntı mevcut. Bu da şu, ölçüm yapılan bazı dönemlerde veri kaybı var. Bu şundan kaynaklanabilir. Ya sistem ya cihaz bir değişikliği yapıldıysa ondan kaynaklanabilir. Bunun haricinde bu değişik yöntemlerle yapılan bu tahminlerde istasyonlar arası mesafe de önemlidir. Bu mesafeye bağlı olarak aslında bu tahminlerde de bir hata oranı yüksek de olabilir. Yanlış ölçümler yapılmış olabilir. Eksik ya da yanlış ölçümde de bu iklim elemanının bu tahmin edilmesi regresyon analizi yöntemiyle aslında yapılır. Diğer iklim elemanlarının etkisini araştıran bazı çalışmalar mevcuttur. Şöyle ki güneşlenme müddeti aslında bulutlulukla negatif ilişkilidir ve çok kuvvetli bir ilişki vardır. Bazı araştırmacılar bu ilişkiden bahsetmiştir. Bağıl nem ya da nispi nem ile yine bir negatif ilişki vardır. Aslında bağıl nemdeki ilişki de bu bir şekilde yine bulutlulukla bağlantılıdır. Rüzgar hızıyla da bir ilişkisi mevcut ve pozitif ilişkili olarak bu ifade ediliyor. Yağışla da negatif ilişkilidir ve basınçla da bir pozitif ilişkisi olduğu bazı araştırmalarca bu kanıtlanmıştır. Şimdi bu çalışmada da bu iklim verileri arasındaki ilişki analizi yapıldı aslında. Rize İstasyonu 1960'dan 2010'a kadar olan bu periyotta meteoroloji istasyonundan alınan veriler, bu günlük veriler, bütün hepsi aylık olarak bir düzenlenerek bağıl ya da nispi olarak isimlendirilen güneşlenme müddetinin bu diğer iklim verileriyle olan ilişkisi analiz edilmiştir. Şimdi meteoroloji istasyonundan bu veriler 1960'tan 2010'a kadar elde edilmiştir. Burada ölçülen değerler alınmıştır. Yer gözlem istasyonundan ölçülen değerler. Peki nasıl ölçülür? Güneşlenmeden bahsettik. Bulutluluk da bugün de 3 kere 7, 14, 21, nem benzer şekilde 3 kere, rüzgarda 3 kere ya da 24 saat olarak ve yağış da benzer şekilde ya günde 3 defa 7, 14, 21 ya da 24 bu saatlik bir ölçüm biçimde ve diğerleri de benzer halde. Peki korelasyon analizi yapılmadan önce her ay için gün uzunluğu hesaplanmıştır aslında. Çünkü literatürde doğrudan burada ölçülen güneşlenme yerine gün uzunluğu hesaplarıyla bu değerin nispi olarak elde edilen bir diğer bu değerinden yararlanılır. Bu hesaplamalarla ilgili aslında burada bu formüller bu haliyle verilmiştir. Şimdi burada fi enlem açısı, delta deklinasyon açısı, bu da güneş ışınları ile ekvator arasındaki açıdır. J deklinasyon açısındaki bu J değeri de her günü ifade eder. Mesela J1 ise 1 Ocağı bu temsil eder. Korelasyon analizi nedir? İki değişken arasındaki ilişkinin hem düzeyini hem de yönünü ifade eder aslında. Ve bir katsayı olarak hesaplanır. Bu katsayıda eğer bulunan bu değer eksi 1 ile 0 arasındaysa bu ilişkinin negatif olduğunu, 0 ile 1 arasındaysa bir pozitif ilişki olduğunu ifade eder. Bir de belli aralıklar için düşük, orta, yüksek olarak bu düzey bir tanım yapılır. Şimdi burada Benreze istasyonu için bu değişkenlerin yani işte bağıl ya da bu nismi güneşlenme için tüm iklim elemanlarının ilişkisini inceledim. Burada %5'lik bir önem bu düzeyinde. Tüm katsayıların değerleri hesaplandı. Çift yıldız %1'lik bir hata payını temsil ediyor ve tek yıldız da %5'lik bir hata payını bu temsil etmektedir. Yıldızlı olanlar istatistiksel açıdan bu açıdan önemli olan bu ilişkileri ifade etmektedir. Şimdi burada da bu ilişkinin yönünü ifade ediyoruz. Yani hem bulutluluk, nem, rüzgar hızı, yağış, basınç ve bu sıcaklıklar için bu ilişkinin tüm aylarda negatif mi, bir pozitif ilişki mi var? Bu şekilde bir tablo halinde bu ilişkilerden bahsedilmiş. Burada da tüm değişkenler arasındaki, tüm iklim elemanları arasındaki bu ilişkilerin hangi düzeyde olduğundan hem yönünden yani negatif mi pozitif mi tüm iklim elemanları arasındaki bu ilişkiler tüm aylar için bu kısımlarda ifade edilmiş. Bu kısımda kış ayları için, bahar ayları için, bu yaz dönemi için ve bu sonbahar için tüm ilişkilerden bahsedilmiş. Korelasyon analiziyle bağlı veya nispi olarak ifade edilen bu güneşlenmenin diğer verilerle ilişkileri analiz edilmiştir ve hepsiyle yakından ilişkili olduğu buradaki analizde ifade edilmiştir. Burada daha önceki o çalışmalarla bir paralel olarak bulutluluk, bağıl nem ve yağışla bir negatif ilişki vardır. Rüzgar hızı, basınç ve bu sıcaklıkla da bir pozitif ilişkili olarak burada elde edilmiştir. Ve bulunan R değerleri düşük, orta ve yüksek olarak tüm değerler bu kısımda hesaplanmıştır. Bazı durumlarda R değerleri bu düşük olarak elde edilmiştir. Bunun nedeni de şu olabilir. Bu aylarda yapılan ölçümlerin muhtemelen bir hatalı ölçüm yapılmış olabilir. Birincisi bitti. İkincisinden devam edeyim mi?
Buyurun devam edebilirsiniz, dinliyoruz.
Tamam. Bir saniye.
Sorularımızı ikinciden sonra
Olur.
Buyurun.
Bir saniye. Samsun içinde ikinci slide. istatistiksel modellerin elde edilmesi yine burada ama yağış miktarı ve nem ile ilişkili olarak. Şimdi ilk başta tanımlar bir öncekiyle aynı çünkü
Evet.
bu konuda iklim elemanları aynı olduğu için bu kısmı ben atlayayım.
Tamam.
Ölçülmesini de atlayayım. Regresyon analizinden bahsetmiştim. Ölçülmesi de benzer şekilde olacaktır. Burada metottan bahsedeyim. Regresyon analizi nedir? Bu kısımdan ben bir devam edeyim.
Buyurun,
Şimdi
dinliyorum.
regresyon analizi, duyamadım, pardon.
Buyurun, dinliyoruz.
Tamam. Y bağımlı X bir bağımsız bir değişken olmak üzere iki değişken arasındaki neden ve sonuç ilişkisini matematiksel model olarak bu ortaya koyan bir yöntemdir aslında. Şimdi matematiksel modeli açıklayacağız ama burada bir öncekiyle yine yaptığımız gibi yani bir ilişki analizinde yaptığımız gibi aslında ölçülen değerler yerine literatürde yer alan gün uzunluğu hesabı için bu değeri biz kullanacağız bu kısımda. Bulutlulukla ilişkisini ifade eden birçok bu çalışmada mevcut olan matematiksel bir model var. Bu formülde ifade edildiği haliyle yani burada ölçülen ve gün uzunluğunun bir oranı eşittir A artı B çarpı N. N burada bulutluluğu bu ifade ediyor aslında. Bu ispatlanmış bir formül. Bunun üzerinden ilerledim ben de. Yani burada madem bulutlulukla bu güneşlenme arasında bir yüksek ilişki var ve bu da ispatlanmış. Bunun üzerine yağış miktarı ve nem biz koyduğumuzda biz bu modelleri nasıl elde ediyoruz? Aslında onunla ilgili bir çalışma yaptım burada. Şimdi bu kısımda regresyon analizinde iki önemli parametre mevcut. Yani istatistiksel olarak modelin anlamlılığını ifade eden aslında iki parametre var. Biri belirtme katsayısı R kare olması lazım burada üst tarafta. Altta da bir hata değeri hesaplanır. Peki R kare nedir? Modelin verileri ne kadar iyi uyduğunun bir göstergesidir aslında. 0 ile 1 arasında bu değişir. Yani aslında yüzde olarak ifade edilen bir değerdir. Yani bağımlı değişkendeki değişmelerin yüzde kaçının bağımsız bu değişkenlerce açıklandığını ifade eder ve burada 1'e yakın olması bu değerin modelin verileri çok iyi uyduğunu gösterir. Burada yazılan formülle hesaplanır. Burada Y, E bu tahmin edilen bu değeri, Y, O da meteoroloji istasyonundan elde edilen bu bir ölçüm olarak ifade edilen o değeri gösterir. Sonrasında bu ikinci başlıkta da bir hata değeri hesaplanır. Burada yine hem tahmin hem de ölçüm arasındaki o farkı ifade eden bir değerdir. Neydi? 1960'tan 2010'a kadar bu toplamda 51 bu tane olan bir gözlemi ifade eder. Burada yine bu formüllerden az önce bahsetmiştim. Gün uzunluğu hesaplanırken bu formülden yararlanılır. Bu kısmı atlayayım. Şimdi burada aslında bu regresyon analizinde birkaç yöntem var. Benim burada bu kısımda adını sağdan yararlandım. Bunun nedeni de şu, aslında bu regresyonda modele katkısı en çok olan hangi değişkenlerse modelde o kalıyor. Diğer önemsiz olanlar yani daha az katkısı olanlar modeli hiç alınmıyor. Bu nedenle aslında bu model çok yaygın bir şekilde bu tarz bu çalışmalarda bu kullanılır. Burada amaç en yüksek verimli halde ve hatanın da en az olduğu bu halde bu modelleri yani matematiksel modelleri elde etmek. Oluşturacağımız model burada bu formüle yazdığım bulut, nem ve yağış için en genel halde yazdım ama formülde hepsi olmaya da bilir. Yani modellerde hepsi de olmayabilir. En katkısı olan hangisi ise modellerde o yer alacaktır. Burada şimdi bu analizi yapmadan önce normallik bir testi uyguladım. Çünkü aslında istatistiksel yöntemler uygulanmadan önce bu verilerin normal bir dağılıma uyup uymadığının bir testi yapılır. Ve bu kısımda aldığım meteorolojik parametreleri de zaten bu testi geçmiştir. Burada da her ay için yapılan matematiksel modeller, bir tahmin modelleri tüm aylar için hesaplandı ve yan tarafında R, bu R kare, bir yanında hata değeri, F değeri istatistiksel bir değer. Bu değeri de model bu kendisi otomatik bu hesaplıyor ve yanında da bunun için bir önem düzeyi var. Bu değerin de %5'ten küçük olması önemli ki burada hepsi zaten modelin anlamlı olduğunu ifade ediyor. R kare değeri yine ne kadar yüksekse model verilere o kadar uyumludur. Burada baktığımız zaman aslında genel itibarıyla modeli uyumlu, ancak Temmuz ve Ağustos'ta biraz bu düşük çıkmış. Orada da ya modelde bir uyumsuzluk var, başka bir model tercih edilmeli ya da oradaki verilerde bir sorun, yani yanlış ölçüm olabilir aslında. Onun dışında tüm modellerde aslında tüm parametreleri dikkate aldığımız zaman verilerin bu modele uygun olduğunu görüyoruz. Burada yine bu R kare, bu değerlerin orta ve iyi derecede, yani 0 işte 54'te 0 bu 87 arasında bir çıktığı. Şimdi biraz önce bahsettiğim Temmuz-Ağustos içinde bu değerlerin biraz bu düşük olduğu bu kısımda bahsedilmiş. Şimdi hem bağım hem de yağış aslında bu kısımda, bu bölgelerde bu güneşlenmeyi etkileyen bir parametre olması çok normal. Çünkü her mevsim neredeyse yağışlı olan bu bölgelerde aslında bu parametrelerin hem nemin hem de yağışın etkin olması bu beklenen bir durum. Bunun haricinde güneşlenmeyi etkileyen bir diğer faktör de aslında o bölgeler üzerindeki atmosferik bir hava hareketi. Yani hem bu illerin ya da bu bölgelerin o kısımda yer alan bir coğrafik yapısı. Bunlar bu kısımlarda aslında tüm bölgeler için, ama özellikle şimdi biz bu kısımları bir çalıştığımız için bu yerlerde atmosferik hareketler ve bu coğrafik yapılar bulutluluk haricinde bu güneşlenmeyi bu etkileyen bir parametre olarak bu kısımda yer almış olabilir. Şimdi modelden bahsedeyim. Adımsal regresyon modeli, hani biraz önce de aslında modeli bir tanımlarken bahsettim. Bu tarz iklim çalışmalarında çok iyi bir sonuç veriyor. Çünkü modele en çok bir katkısı olan hep tercih edildiği için burada zaten modelin verimliliği yüksek. Sadece gözlem miktarı artarsa bu tahmin başarısı bu daha da artacaktır. Ve bunun haricinde olan bir çalışmalarda, yani iklim ve meteoroloji ile ilgili olan bu çalışmalarda da bu modelden yararlanıldığında yine bir tahmin başarısı yüksek olacaktır. O yüzden bu kısımda onu da önermiş olmak istiyorum ve teşekkür ediyorum. Paylaşımı kaldırayım.
Is there any question, comments or remark? No question. Burada hangi tür regresyon model analizini kullandınız?
Burada adımsal regresyon hocam. Az önce bahsettiğim modele
Yani,
en çok bu katkısı olan bir kabul ediliyor. Onun dışındakiler zaten modelden eleniyor.
Doğrusal mı?
Doğrusal regresyon, evet hocam.
Tek değişkenli mi, çok değişkenli mi?
Çok değişkenliden yararlandım.
Çok değişkenli, doğrusal.
Evet.
Hangi programı kullandınız?
Buradaki SPSS programıydı.
SPSS.
Başka programlar da var ama benim kullandığım SPSS programıydı.
Evet. Teşekkür ediyoruz sunumunuz için.
Ben teşekkür ediyorum. İyi çalışmalar dilerim.
Okay. The last two presentations of this session will be given by Svetlana Maldenova. The title of her first talk is A Feature Wavelet Rule for the Key Nearest Neighbor. And her second talk is Machine Learning in Business, a Short Overview.
Hello, let me just share my screen. Do you see my presentation?
Right, yes, you can start.
Yes. Okay. Hello, my name is Svetlana Maldenova, and I am a PhD student at the University of VROOM3, Department of Computer Systems and Technologies. Today I'm going to present you two papers, and the first one is a feature weighted rule for the nearest neighbor. The nearest neighbor is an algorithm, one of the earliest, most used, and most intuitive machine learning algorithms. Presented in 1952, it has proven to be stable, robust, and applicable in different areas, both in research and in real life. The idea is to classify an unknown sample into a class based on the classes of several close samples. The number of those closest samples is determined in several ways, but the most common way is the experimental way, by training a model with a range of values and pinpointing the value from which the accuracy of the model decreases. Some of the problems specific to this machine learning method, the KNN, is the sensitivity of the chosen k value, the number of the neighbors, which will be used for the training, and hence the size of the neighborhood. The selection of the samples that are going to be included in that neighborhood, and the classification time, and finally the voting mechanism. Although the algorithm is an excellent choice for many scenarios, usually its limitation, these four main four limitations, are the reasons why it's not used as a standalone solution. Many authors are pointing the need to modify the traditional algorithm in order to improve the accuracy or use it in a combination with other methods and algorithms. Some authors are proposing an approach in which the k value is calculated automatically based on the size of the training set. And it's a very interesting and working solution. Regarding the choosing of the neighbors, some authors use the most used actually method is the Euclidean distance, but many authors are using using and proposing other solutions such as the Minkowski distance, the Chebyshev distance, or entirely new algorithms such as the nearest centroid neighborhood. And the voting mechanism problem is actually the problem that which will be addressed in this paper, and for which possible solution we are going to try to give. The first weight-based KNN modification is presented in 1976, quite a long ago, as a combination of weighting function and a decision rule at the stage of classification. The author relies on the assumption that observations from the same class tend to be close to each other. The presence of a weighting function can help distinguish the members of different classes based on the distance and the manner that its value decreases with the increase of the sample to neighborhood distance. That's the formula with which the weight is calculated, and it's entirely based on the distances, where D1 is the distance from the unknown sample to the first neighbor, dk to the last neighbor, and di to the current neighbor in the neighborhood. And in the case that the first and the last are the same, the value is 1, meaning that's the closest neighbor. It should be noted that the calculated weight varies in the range of 0 to 1, accordingly to the distance of the weighted sample to the unknown sample. The neighbor that is closest is given the value of 1, and the one that is farthest from the unknown sample is given the value of 0, meaning that the actual number of neighbors that are used in the classification step is k minus 1, not k, but k minus 1. There are many other different weight functions, modifications, which are based on this one. And these are just one of them. The first, which is shown here, presented in 2008, is the uniform function, which is based just on the number of the neighbor in the neighborhood, ordered increasing in the distance. The other two weight functions reviewed in this paper are the dual weight and the new distance weight functions, which, if we can see this formula, is actually the base weight function multiplied by the uniform function. And the new distance weighted function is again based on the base weight function. The requirements for the proposed solution are as follows. Since the selection of the K value is one of the problems that the KNN algorithm faces, the proposed solution should achieve satisfactory results both with small and large values of K. The proposed method should be applicable to small and medium data sets, and thus the ability to have high accuracy with a small value of K should have precedent over the ability to accurately satisfy and classify with large values of K. The proposed solution should be optimal when dealing with small data sets, and therefore every neighbor in the neighborhood should be considered in the voting mechanism. And weight functions in which a neighbor receives the weight of a 0 should be avoided if possible. In many cases, the datasets are not balanced and have outliers. The solution should be able to classify accurately as possible. Again, both unbalanced datasets and those with outliers. All of the reviewed weight functions are using a form of distance between the object and the unknown sample in order to compute the weight. Starting with the first weight function, the oldest one, the author is computing the weight based on the distance of the current object in the neighborhood to the distance of the first sample and the distance of the last sample. The other modifications of this algorithm, the dual, the DWKNN, also uses the same distances. The uniform function calculates the weight based on the order of the neighbors, and since that order is obtained after the computation of the distances, we can argue that this method also relies on the distance to calculate the weight. All of the reviewed methods are using, with the exception actually of the uniform method, are using K-1 neighbors when classifying. And since the last neighbor always receives the value of 0, and when the voting mechanism, the voting classification mechanism is done, this last neighbor is not taken at all into the consideration and the classification. The proposed solution does not take into account the distance at all. The role of the distance between the unknown sample and its neighbors extends only to the formation of the neighborhood on the steps of the choosing the neighbors that will be included. The basic concept of the algorithm is to compute the weight based on the features of every sample, where xi is the neighbor in the neighborhood, every neighbor. And the solution is simple enough to be suitable for implementation and application. The features for every sample in the neighborhood are summed up, and since the possibility of the sum being equal to 0 is quite small. Every neighbor in the neighborhood is participating in the voting. For the sum of the sample to be equal to 0, that would mean that either all of the features are 0 or the sum in some case is 0. And in both scenarios, a sample with a 0 sum would be excluded from the voting mechanism, just as the previous weight functions, because it does not give any value to the overall classification. And from the concluded experiments, which we'll see in the next few slides, there was no case where the computed sum of features was equal to 0, or the case was very small. The algorithm of the proposed solution is as follows. The input is an unclassified sample and, of course, the training set. First, we calculate the distance between the unknown sample and every sample in the training set with the Euclidean distance or with any other available and known distances, but all of the following experiments are done with the Euclidean distance. After that, we are sorting the training samples from closest to farthest. We are selecting the first k samples to form the neighborhood from these ordered samples from the previous step. And for every neighbor in the neighborhood, we compute the weights. We compute the sum of the features, and we are checking if that sum is equal to 0. If the sum is equal, in fact, to 0, the overall weight is 0. That neighbor will actually be excluded from the voting. But if the sum is not equal to 0, we compute the weight according to the formula from the previous slide. The next step is to compute the weight sum for every class from the neighborhood. And we classify, at the final step, we classify the unknown sample into the class that has the largest weight sum using the majority weighted rule presented from the weighted KNN, the first weighted KNN. The experiments conducted are done on several well-known and used data sets. The selected data sets are various in the manner of number of instances, attributes, and classes. 4 of the data sets are imbalanced. Those are the beavers, the breast cancer Wisconsin dataset, the thyroid, ionosphere, and actually the Facebook fake news, which I'm going to explain a little bit later. 3 of the data sets are reported to have more than 30% outliers. Those data sets are Pima Indian diabetes, the breast cancer Wisconsin, and the ionosphere with 36% outliers. 2 data sets actually are from the are examples considered to be small n and large p problem, where the number of the attributes, the features, is larger than the number of instances. Those are these 2, the leukemia and the SCRBT dataset. The additional dataset, the Facebook fake news, is also tested and considered. It consists of real-life Facebook posts, Bulgarian Facebook posts, which aim to classify fake news, various fake news. And this set is actually considered to be the real-life example of data, where we have around 154 true news, actually, and the rest 1,000 news are false. That's why this data set is considered to be also imbalanced. All of the experiments are conducted with a 10 k-fold cross-validation, and for every data set, the whole list of the available features is used, and the model is trained with. The results can be summarized in this following table. When reviewing the results, the accuracy of each model is compared, and this table shows the accuracy of the tested algorithms and the number of the neighbors with which that accuracy is achieved. For example, 98% with a number of 11 neighbors. From the conducted experiments, it's visible that the proposed solution, the last two columns, achieve satisfactory results, and in some cases even outperforms the other algorithms, or in some cases performs as equal as other well-known and well-used algorithms. What is notable is the low number of neighbors needed to achieve high accuracy. In the traditional KNN algorithm, the average rate of needed neighbors when taking into account all of the available features is 7, where in the tested solution in our proposed method, the number is 8, which is significantly small comparing to some other weight functions where the average number of needed neighbors is 20, 90, more than 15. The following figures are the visual representation of the change of the accuracy with the change of the k-value for some of the tested data sets, not all of them. In this figure, the proposed solution is denoted as test, and it's also the red line. The first figure is the dataset beavers, which is the example of imbalanced datasets. Again, we see that the proposed solution achieves satisfactory results. The right upper figure shows the Pima Indians diabetes dataset, the example containing high percentage outliers. We can see that this proposed solution outperforms some of the best known and most used solution. The third figure actually is the visual representation of the flows of the model when the dataset is both imbalanced and contains high percentage of outliers. Actually, in this case, the proposed solution performs worse. In conclusion, the proposed algorithm feature weight KNN achieves results that are comparable with some state-of-art algorithms, and the percentage of accuracy remains high even with a small neighborhood, which makes the algorithm suitable for small datasets. In some cases, the best results are achieved with only one neighbor, meaning that the algorithm behaves like a nearest neighbor. Even when the dataset is from the type small n, large p problems, the algorithm still shows satisfactory results and can be used. And since the weight is almost never zero, all of the neighbors in the neighborhood are participating in the voting process. All of the conducted experiments show that even though the accuracy of the feature weight KNN is high, it can be further improved. The current state of the algorithm does not take into account the distance or the distribution of the classes in the training set. Those are some areas that can be further tested, and some modifications to the function can be made. The algorithm is simple and easy to implement, and overall the proposed solution is suitable for classification and can be used for such purposes. Thank you for your time. If you have any questions.
Is there any question, comment, or remark? No question. Thank you very much for your presentation. You can start your second talk.
Okay.
Please pay attention to the duration of presentation, 10 minutes, okay?
Okay, this one is a quicker, shorter. Okay, well, machine learning is viewed as one of the most progressive and research areas in recent years. And with such a broad application area, it's only natural that the businesses would want to benefit from it. And in 1993, Davenport was the first one to give a definition of a business process, a structured measured set of activities designed to produce a specific output for a particular customer or market. Following his definition of the business process, many authors have tried to give their own definitions, but they all circle to the definition that emphasizes the set of activities and not that paying much attention to the final product. And if we can see the history of the businesses in the last decades, we can see that the 60s were the years where the main question was how to produce more, meaning that the quantity was important. The 70s were denoted by how to produce cheaper, meaning that the cost was the most important factor. The 80s were denoted by how to produce better, with the quality being the main factor. The 90s were denoted to how to produce faster, the time being the main factor. And we see that the 21st century is moved by the question how to offer more, meaning that the services were the main factor that moved the business. What's interesting is that one of the first interpretation of the term business processing with the meaning of machine learning in business processes and processing is suggested in 1992, which was quite a long ago, almost 30 years ago. When implementing machine learning in businesses, there are some challenges which the businesses are being faced with. They can be mainly divided into three groups: ethics, quantity and quality of data, and cost benefit challenges. Although machine learning is seen as innovation, there are serious disputes about the ethical part of its usage. Even created with good intentions, a machine learning model can raise many ethical issues and undermine the prestige of the organization that uses. In recent years, we have witnessed quite a few such cases and research on the subject. While training the model, it will be trained only with the data that it's given, meaning that it's completely dependent on the data, in particular, the people who have gathered that data and who have processed it. Some authors claim that the algorithms for machine learning and artificial intelligence should reflect the ethical principles of the people working in the organization that uses these algorithms. And when talking about applications of machine learning in business organizations, usually it's meant medium to large organizations that can actually afford the implementation cost of such algorithms. Except for the implementation cost, there is another reason why these technologies tend to be used by larger companies, and this is the quantity and quality of the data. To be able to train a model, a big set of data that is processed in a way that's most valuable for the model is needed. However, if the data is not enough, the probability of errors increase. And a lot of small businesses and even medium and some large businesses are not fully digitalized yet, and their processes are manual, and the data from pre and post operations are recorded on paper, which is also a factor for the quantity and the quality of the data. And in some reports from last year, the percentage of American companies using some form of artificial intelligence is around 9%, from which 9%, around 25% is used by mostly large companies. And when choosing actually the suitable algorithm for one problem, that can be also challenging because one algorithm can be suitable for one problem, but it can be also completely inapplicable for another problem. Every algorithm can have multiple modifications and variants, and this variety makes it difficult to choose a suitable algorithm. And in such cases, the uses of several models are needed. And when choosing an algorithm for building a model, an important factor is the trade-off between the accuracy and the interpretability of the algorithm. The accuracy of the model is determined by the errors that can be avoided and the ones that cannot. It should be assumed that selected algorithms will not be 100% efficient, and some of the samples will not be classified correctly. In order to avoid and to solve this problem, at least partially, a more suitable algorithm should be found. But even if there is an algorithm that gives 100% efficiency, there is a chance that there are errors that cannot be avoided. The errors such as missing data or unprocessed data features, for example. While for academic and scientific purposes, it's not obligatory for the algorithm to be understandable. That's not actually the case for businesses. When one manager has to decide on the future of his company, of their company, based just on the results of some machine learning algorithm that he does not understand, he would not want to do this decision, and he would want to know how the model came to that decision. An algorithm for machine learning can be defined as understandable if its classification can be explained with a simple set of condition statements, for example, if-else conditions, or can be shown in visual and textual ways. For example, the model of the black box on which many machine learning algorithms are based does not give a clear idea of its internal mechanisms and how it works. And some simpler algorithms, such as the k-nearest neighbor, the decision trees, linear regressions, are more likely to be understood by people, by managers, by the business, by the overall business. In conclusion, we can say that usually more than one algorithm could be used in a business organization, or not just business organizations, because usually different problems require different solutions, different models. There is no one algorithm that can be used every time. Every machine learning algorithm that is chosen must meet some basic certain criteria. For one, being able to handle small sets of data and having small computational resources, because small to medium businesses cannot afford the high computational costs of some state-of-the-art algorithms, models. And missing or incorrect data should not render too much influence on the accuracy of the model, which should not be that big of a problem because it usually cannot be avoided. And the algorithms used for businesses must be easily understandable by not only by those who train them, who make them, but mostly by those who use them on a daily basis, such, for example, and usually the business managers. And that's actually my very short overview of machine learning in businesses. And if you have any questions, I'm happy to answer them.
Is there any question, comments, or remark? No question. Thank you very much for your nice presentation.
Thank you.
Thank you very much for your participation to this session.